Hi and welcome. In this video, we will see how we can construct two-way tables. To that end, consider two statistical variables x and y, and suppose we have collected data on both of these variables from an underlying population, and we have listed data on x as x1, x2 up to xn, and on y as y1, y2 up to yn. Then a two-way table can be constructed in three different cases. To study all three cases, consider the case where we have collected data on salary, education, gender, and working hours from all 10 employees of a technology company in Kabul, and we have recorded data in this table: gender, education, salary, and working hours. The first type of two-way table can be constructed for two qualitative variables such as gender and education. We know gender and education are having limited number of values, namely gender has two values, male and female. Education in this case has high school, bachelor, master's, and PhD, four different values. To construct the two-way table for education and gender, what we do is on the first column, we consider the values of gender, female and male. And on the first row, we consider different values of education, such as high school, bachelor, master, and PhD, respecting the order of education level. Then we see how many females are having high school, how many females are having bachelor's degree, master's degree, and PhD degree. Looking at the table here and looking to the data here in the table, we see that no female is having high school, no female we have with bachelor's, we have two females with master's, one female with PhD. In total, we have three females. That is the total number of females we have. Likewise, we count the number of males with high school, number of males with bachelor, same with master's and PhD. Looking at the data here on this table, we see that we have two males with high school, four males with bachelor's, one male with master's, and no male with PhD. In total, we have 7 males. Of course, 7 and 3, this is 10, which is the total number of observations. Down here, we have 2 people with high school, 4 people with bachelor's, 3 with master's, and 1 with PhD. The same if you add these numbers, 2 plus 4 is 6, plus 3 is 9, plus 1 is 10, which gives us again the total number of observations. In the second case, we consider the two-way table of a qualitative variable and a quantitative variable. In this case, again, we in the first row list the values of the qualitative variables such as high school, bachelor, master, and PhD for education. And then we define different categories for the salary. Here, I have chosen salary less than 20,000 as one category, between 20 and 30,000 as the second category, and more than 30,000 as the third category. Like the first case here, we see how many high school people having a salary less than 20,000. We see that 2 persons with high school have a salary of less than 20,000. No high school between 20 and 30,000, and no high school more than 30,000. And in total, we have 2 people with high school's degree. Likewise, with bachelor's, we have 4 people between 20 and 30. As a result, we have 4 people in bachelor's degree. For master's, we have 3 people with salary more than 30,000, no one in the second category, no one in the first category. With PhD, again, we have 1 person whose salary is more than 30,000. And again, the sum of each value of education is being given here in the last column, and the sum of each value for the different categories of the salary are given down here in the last row. 2 people having a salary less than 20,000, 4 people having a salary of between 20 and 30,000, the last 4 people having a salary more than 30,000 people. Of course, the sum of the last column or the last row is 10. These frequencies in the middle is what we refer to as joint frequencies. The frequencies in the last column, which belongs to education, and the frequencies in the last row, which belong to the salary category, there we refer to as marginal frequency. When it comes to the conclusion whether the two variables are associated or not, the more different are the joint frequencies, the higher is the association. For instance, as we change the value of education from high school to master's to PhD, the number of people who are having higher salary is increasing. It seems that the higher is the education level, the higher is the salary. And that's what do we mean by the association between two variables. The third case of two-way table is the two-way table of two quantitative variables, here working hours and salary. In order to construct the two-way table for working hours and salary, first of all, we define different categories for both variables. Here we have defined for working hours 3 different categories: those who are working less than 7 hours, the second category those who are working 7 or 8 hours, the third category who are working more than 8 hours. Salary, again 3 categories: less than 20, between 20 and 30, or more than 30,000. Now we check the data here in the table. How many people do we have who are working less than 7 hours and have a salary of less than 20,000? 2 people. And how many people are working 7 or 8 hours and have a salary between less than 20? No one. Between 20 and 30, 4 people. And those people who are working more than 8 hours, we have no one less than 20,000, no one between 20 and 30. We have 4 people who are having a salary of more than 30,000. Again, these are the marginal frequencies. These are the joint frequencies. Again, we see here, as we increase the number of working hours, the salary increases. And that's a sign of association between working hours and salary. In other words, we can conclude from this two-way table that working hours and salary are associated, in the sense that with working hours increasing, the amount of salary also increasing. Thanks for watching and good learning.